So in this video, let us look at the theorems that we have regarding the number of roots of a polynomial equation. So if you have a polynomial equation of the form f of x is equal to 0. So whenever you write a polynomial is equal to 0, this becomes a polynomial equation. So if you have a polynomial equation, a number alpha is called a root of this equation. A number alpha is called a root of this equation if and only if f of alpha is equal to 0. So if you put alpha in the place of x in the polynomial, and if you get 0 as the answer, then we say that this number alpha is the root of this equation. For example, if you have x square minus 5x plus 6 is equal to 0, let us consider this as my f of x. Now, what is f of 2? F of 2 is equal to 4 minus 10 plus 6 is equal to 0, right? So f of 2 is equal to 0. This implies 2 is a root of this equation. So this works in both the ways. F of x is equal to 0. Alpha is called a root if f of alpha is equal to 0. And if f of alpha is equal to 0, then alpha is called a root. So this is the meaning of the root of an equation. So what is another interpretation of the root? So f of x is equal to 0 has alpha as a root. F of x is equal to 0 has alpha as a root if x minus alpha divides f of x. Can I say this? Yes, from remainder theorem and factorization theorem. So if f of x is equal to 0 has alpha as a root, by definition f of alpha is equal to 0, and if f of alpha is equal to 0, from factor theorem x minus alpha has to be a factor of f of x. So these are two ways in which we can determine whether a number is a root of the equation. So now that we have understood the meaning of root of a polynomial equation, let us look at what repeated roots are. So you come across this word often, repeated roots, and the corresponding concept is multiplicity of roots. So let us see what this is. For example, if you have a polynomial f of x, if f of alpha is equal to 0, then I can say that x minus alpha is a factor of f of x. X minus alpha is a factor of f of x. Now, there might be some situations where f of x will be divisible by x minus alpha whole square also. There might be some situations where f of x is divisible by x minus alpha whole square. For example, if f of x is equal to x minus 2 whole square times x minus 3. X minus 2 whole square times x minus 3. Here, x minus 3 is a factor, and x minus 2 is also a factor, and x minus 2 whole square is also a factor. Now, in this situation, we say that 2 is a repeated root. We say that 2 is a repeated root with multiplicity 2. With multiplicity 2. And if you have another example, f of x is equal to x minus 2 whole cube times x minus 3 whole square times x minus 4. So in this case, we say that x minus 2 is a factor of multiplicity 3, and 2 is a repeated root with multiplicity of 3. and 3 is a repeated root with multiplicity of 2, and 4 is not a repeated root, or we can say that 4 is a root with multiplicity of 1. So now I hope you understand what repeated root is and what the multiplicity of a repeated root is. So the multiplicity of a repeated root is more than 1. For a general root, the multiplicity is 1. For a repeated root, the multiplicity is more than 1. So if I have to give it a definition, alpha is called a root of f of x with multiplicity r. Multiplicity r if x minus alpha whole power r divides f of x, and x minus alpha whole power r plus 1 does not divide f of x. So I am looking for the maximum multiplicity. Alpha is called a multiplicity of 2. For example, alpha 2 is called a root with a multiplicity 2 if x minus 2 whole square is x minus 2 whole square divides f of x, and x minus 2 whole cube does not divide fx. Because if x minus 2 whole cube also divides fx, then the multiplicity will be r plus 1. So if the multiplicity is r, multiplicity is a unique number. So if the multiplicity is r, x minus alpha whole power r should be divisible by f of x, divides f of x, and the next power should not divide f of x. Then we say that alpha is a repeated root with multiplicity r. So once we understand the concept of roots, the fundamental theorem of algebra says that a polynomial equation of degree n has exactly n roots in the set of complex numbers. So every polynomial equation of degree n has exactly n roots in the set of complex numbers. So when I talk about roots, a root of multiplicity 2 has to be taken as 2 different roots. That is, if f of x is equal to x minus 2 whole square into x minus 3, clearly we can see that this is a cubic equation. So what are the roots of this equation? The roots of this equation are 2, 2 and 3. Because 2 is a repeated root, you have to take it as 2 times. So 2, 2 and 3, you have a total of 3 roots. So every polynomial of degree n has exactly n roots and no more. And no more. That means f of alpha will be equal to 0 only n times and not more than that. If someone claims that, if in a problem it is claimed that a polynomial equation has more than n roots, then there is only one option, then it becomes an identity. That is, all the coefficients have to be 0. All the coefficients has to be 0. So if a polynomial equation of a degree n has more than n roots, if it is claimed that it has more than n roots, then there is only one option, all the coefficients have to be equal to 0. For example, if some coefficient times x square plus some coefficient times x plus some coefficient is equal to 0 has 3 roots. So if someone claims that it has 3 roots, it means for 3 different numbers, if this equation is getting satisfied, for 3 different numbers, if this equation is getting satisfied, then there is only one option. This has to be equal to 0. This also has to be equal to 0. This also has to be equal to 0. Then this becomes an identity. It means for whatever value of x, this equation is valid. So for any polynomial equation with whose coefficients are not all 0. There are exactly n roots correspond to a degree n. This is called the fundamental theorem of algebra and the most important theorem.